I hope you're excited about implicit differentiation. I love these problems because it's our stepping stone to related rates, and those are my favorite problems in this chapter. I'll see if I can make you excited about these. Find dy dx for xy plus y equals 8 at the point 2, 3. Now, normally if I wanted to find the derivative, I would solve for y, but the way that y shows up in two places like that is going to be tricky to solve for y. And so we want to solve this implicitly. So to solve implicitly, what I'm going to do is first I'm going to look at this term, and I see I've got a first and a second. And so if I start taking the derivative, I've got the first times the derivative of the second. Now if I take the derivative of y, I get 1. But because y is not an x, okay, I need to add this chain rule, so I have dy dx. Okay, because the x that I'm differentiating with respect to doesn't match the variable, I've got to follow the chain rule and I got to do that dy dx. So I got the first times the derivative of the second plus the second times the derivative of the first. The derivative of x is just 1. And for what it's worth, we've always been following the chain rule, right? If I followed the chain rule here, if I did 1, the variable is an x, and I'm differentiating with respect to x, dx over dx is just 1. And so we've never shown it before. So we've always been following the chain rule, we just don't show it unless I've got a variable other than x. Okay, let's keep going. I had my first times the derivative of the second, plus the second times the derivative of the first, and then I've got a plus y here, and so the derivative of y is 1, but it's not an x, so I'm going to follow my chain rule, dy dx. And then the derivative of any constant is 0. Clean this up so I can see what I'm really dealing with here. So this is x times dy dx. You could also be using y prime if you wanted to, plus y plus dy dx equals 0. So step 1, I differentiated everything with respect to x. Step 2 is to keep your dy dx terms on the left and move anything that's not dy dx over to the other side. And so that leaves me with x dy dx plus y, plus dy dx, and I'm going to move that y to this side. The next step, if you have more than one dy dx term, and I do, you're going to factor out a dy dx. So if I factor out dy dx, that'll leave me with x, that'll leave me with x plus 1, there's an understood 1 there, and that's equal to negative y. And then get dy dx by itself, so I'm going to divide both sides by x plus 1. And that leaves me with my final answer, dy dx equals negative y over x plus 1. Now I said that was my final answer. I lied to you. If you go back and look at the question, it said find dy dx at this point. That means I've got an x and a y value to plug in to my answer over here. If it had just said find dy dx, I could stop here, but I need to plug in those numbers. So dy dx is equal to negative y over x plus y, plugging in those coordinate points, and so that gives me negative 3 over 5. Now I'm done. It's always worth rereading the question. Let's do another one. Find dy dx for tangent of x plus y equals y. There's no way I'm solving that for y, so I have to solve this implicitly. And what I have is I have a chain rule. I have a function inside a function, so I'm going to start with the outside. The derivative of tangent is secant squared of x plus y, but then I have to take the derivative of my inside. So taking the derivative of x is 1, times dx over dx, but I'm not going to show it because it's just 1, plus the derivative of y is 1, but because y is not an x, I have to do dy dx, chain rule, equals, and then over here I have a y, so that's 1 dy dx. I'm going to take this term and distribute it here. I'm going to have to get those dy dx's out of the parentheses for this to work. So distributing, I've got secant squared of x plus y plus secant squared of x plus y times dy dx equals dy dx. I need to get my dy dx's together and my other terms on the other side. So I'm going to take this term and move it over here. That'll get my dy dx's together. So I have the secant squared of x plus y equals dy dx minus the secant squared of x plus y dy dx. That's a terrible looking y. No, I'm just making it worse. Oh gosh. Okay. Next step, factor out a dy dx. So I'm going to leave the left side alone if that's okay. Factor out a dy dx, that leaves me with 1 minus the secant squared of x plus y. And then I need to get dy dx by itself, so I'm going to divide both sides by this term, and that will leave me with dy dx equals this secant squared of x plus y divided by this 1 minus the secant squared of x plus y. Sure looks like that should simplify, but let's leave well enough alone. I don't think we can simplify that. And that is my final answer.